Okay, so now we are going to see the how to fine tune transform, right? So unlike last time, we are going to train all parameters of the model and we'll train them. Some key changes in the work time will be we'll be using the auto model for sequence classification in place of logistic regression. Last time we used a logistic regression model to train our classification. But now we will use auto model for sequence classification in place of, because unlike the default architecture of DistilBERT, it has a classifier header at the top, so we need not to append one ourselves. What does it mean? It means that this DistilBERT architecture, it was not complete for our use case, right? DistilBERT architecture was just this. It didn't contain a classification layer. So this auto model for sequence classification is DistilBERT plus this classification header. Last time we had to append a classification header by itself, but this time we are not doing it. This time it has been defaultly done by auto model for sequence classification, right? So for fine tuning purpose, we are going to use this model, unlike the logistic regression, right? We'll be defining the batch size, learning rate, etc. thing while training, and we'll use the training arguments, which makes it easy to set up and get the weights into output ready to save and use it later. Say, since this is a actually we will be training a lot of weights, so it is actually we will be giving it more arguments that we will see later that what are those arguments. Okay, so from transformers import auto model for sequence classification. So what we are doing here, we are importing the auto model for sequence classification class from transformers library, right? Num labels is this 6, that is number of output labels being defined to throw as input in the model, right? Now this is the model we are defining, auto model for sequence classification from pre-trained model CKPT, but this model CKPT, it was the pre-trained weights that we downloaded before. Number of labels 6, and then we are storing it to the device that is available, preferably GPU. If not GPU, then CPU, right? Let's run this. Firstly, I guess it will download this auto model for sequence classification. Okay. So what the warning it is giving us? Some weights of DistilBERT sequence classification were not initialized from the model checkpoints. At DistilBERT, uncased are newly initialized. Okay. Classifier wise and classifier wise, pre-classifier wise. Okay. So what is its what happened? I pressed the back button. Oh, nothing happened. It's fine. Okay, so it is saying so it's saying that classifier bias, classifier weight, pre-classifier bias, and pre-classifier weight. Okay, so what's saying that this DistilBERT for sequence classification, this model doesn't have some weights. Okay, like we are loading model CKPT, right? But this model CKPT is a file for DistilBERT. It doesn't have the weights for this classifier layer, classifier header, right? So it is saying some weights were not initialized, and that again these weights are classifier bias and classifier weight. So it's saying that you should probably train this model on the downstream task. Okay, so what we are going to do the same, we are going to train it. Okay, and unlike last time we did the score, we used the by default scikit-learn score function. This time we are going to define. Firstly, we are importing the accuracy score and the F1 score from the sklearn.metrics. Right, and then we are going to defining a custom function for computing the accuracy metrics. Okay, this time we want the accuracy to get because actually if we are fine tuning it like this way now, it will have a higher accuracy than the feature extraction, because this time we are fine tuning the whole model, right? You can study this code. It's very easy. You can get it. You can get familiar with it. Okay, so we defined it. Now we are training the model. Now this is something very interesting. What we are importing? We are importing some very cool things here. We are importing the trainer and training arguments. In machine learning, what happens that we need to pass a lot of arguments when we are actually training some model. Okay, and actually thing is here Hugging Face is very generous and it has given us some custom functions so that it won't be very hard for us to train a model. Otherwise, to write the code for training a model is actually a very long process, not very long process, but very a cool process. But this time, since the Hugging Face has given us very cool things like trainer and training arguments, we can train it in this way. What is it? Okay, so we need to find a batch size. What is batch size? I will explain you. Defining the value of batch size. Okay, so in machine learning, what happens that whenever we are passing some we are passing some data into a model. Okay, so data is passed. If you would have studied in the gradient descent, we have stochastic gradient descent, we have uh, you can say batch gradient descent, and then we have mini batch gradient descent, right? So amount of lines of code then that we are putting it inside the training is called a batch size. Okay, so a batch of 64 lines of code is being sent inside the training model. Okay, defining the value of batch size. Okay, then we have this. This is a logging step, defining the logging step. What is this logging step? Okay, like we are given logs. Okay, so like when we are training a model now, then after every 60, we can say after 100 steps, it will tell us, okay, 100 type this amount of training has been done. After again 100 steps, it will tell us, okay, 200 lines of code has been trained. Okay, so after how much this log should appear, this is called a logging step. So we are defining a logging step that after how much logs it should give us. Okay, so now what is emotion encoded and train length? It is actually 16,000 and 16,000 divided by 64. Okay, so for each batch we are being given a log. After each batch we will be given a log. Okay, and then here model, what is model name? Model name is model CKPT and model CKPT is what? Model CKPT, I guess it is DistilBERT uncased. Okay, this is the name of the model CKPT hyphen fine tuned emotion. This will be the model name. And what are now training arguments? Training arguments, I am saying that output directory is model name. Okay, and this is very interesting that training arguments gives us the functionality of defining an output directory ourselves. Okay, usually what happens that whenever we actually in the last case also when we train a logistic regression, how we will able to reuse it? For that we must save the model, we must save the weights which are trained. Okay, the new weights that we have achieved after that classification layer, because of which we will be able to use it ourselves. Okay, so it will give us the output directory where by the name of model name it will get stored. The output directory will be given as a model name. Number of training epochs is 2. I guess you are familiar with the epochs and how much iteration it should do with the data. So you can increase it also if we think that our data is underfitted. Learning rate is 2e minus 5. Okay. Per device train batch size is equal to batch size. Per device evaluation batch size is equal to batch size. This train batch is this training emotion encoded train, and then eval batch is emotion encoded validation set. Weight decay 0.01. Eval strategy is epoch. Disable TQDM false. What is this TQDM? I will tell you later. Logging steps, and then push to hub true. What is the push to hub? Push to hub is this weight will be pushed to my Hugging Face hub, right? Actually, I can do it like I can put it to false because in my Hugging Face I have already sent it. It's saved, so there's no need to save it again. Okay, right? So I guess these were our training arguments that we need to specify before training. Okay, so let's save them. After setting up all the arguments, let's finally train our DistilBERT and do the validation on the validation set. Okay, so now we are importing the trainer. Next, what is it? Trainer. Okay, so in the trainer, we put all the our arguments. Okay, model is model, args, and all the arguments is saved as training arguments. Compute matrix that the custom function that we made earlier for the to get us the accuracy matrix, etc. Train dataset was a training dataset that its emotions encoded train, and eval dataset is emotion encoded validation. Asha, why we are not using just emotion? Why we using emotion encoded? Because whenever we pass the model, pass the data to the transformer, we want it to get to be encoded, right, in the format on which it is trained. Okay, and tokenizer is tokenizer, and by this command trainer.train, we will start training it. Okay, so it will take some time, right? Now let's look. Okay, so let's. Okay, so it's asking for an API key from the profile and hit enter. Okay, so it we are using actually an API of vandep.ai, so you can also do it. It's quite easy. You just need to log in at once. Okay, I had logged it earlier, so it's not asking me to log in, or I guess it will ask me sign in. Okay, so just a second.